Hello everyone, welcome to Inspired Mechanical. In this video we are going to cover the projection of line problems. These problems are easy to moderate level. In upcoming video I will provide you advanced level problem. So the first problem is a line AB is 100 mm long and it is parallel to HP and VP both. Draw its projection for the following condition. In upcoming slides, three problems are there. One by one I am going to discuss. So the A part says line is 25 mm above HP and 25 mm in front of VP. See, this is my VP and this one is HP. This capital AB is our given line which is having 100 mm length and it is 25 mm in front of VP and 25 mm above HP. We need to draw its projection. So I am observing my front view from here. So this red color line denotes our front view, right? So A dash and B dash is the projected front view of this particular line, and this small AB which is green in color, when I'm seeing from the top, it is projected on a HP. So how the projection of this line is being made? First of all, I need to draw XY line, right? And above this line 25 mm above HP and 25 mm below HP. That is, after rotating HP 90-degree clockwise, 25 mm distance is projected below the XY line. So we need to draw two lines parallel to each other. One line is this one and it is having dimension 100 mm and its name is which one? A dash and B dash, right? And just below that we need to project its top view which name is small AB. This one is the required projection of line, and 100 mm dimension 100 mm dimension we need to do in this way: 1:3 arrowhead, and this 25 mm and 25 mm distance is the equidistant. You can also say this line is equidistant from the HP and VP both. So this blue color denotes we need to draw this line with the help of 2H pencil, and the rest of line which I have drawn with the help of black pen, we need to draw either H pencil or HB pencil. So this is the standard for our line. So in the second problem, the line is same 100 mm long and it is parallel to HP and VP both, but B part we are going to cover. Line is 30 mm above HP and on the VP. See, on the VP and in the VP are the same thing. So this is the capital AB is the given line which is having 100 mm dimension, and when I am seeing from the front, this is our HP and this is our VP, both are perpendicular to each other. I am observing from infinite distance in this direction. So front view is projected where the line is lying itself. A dash and B dash are denotation for that one. And when I am seeing from this yellow side, this is the top view side, the line is projected red in color, which is its required. Small AB is the top view. This 30 mm distance, this 30 mm which I have denoted with blue dotted color, is the above HP distance. Line is not having in front of VP distance because line is lying on the VP, right? So how we are going to do the projection of this line? We need to draw XY reference line initially. This is named XY with the help of H or HB pencil, whatever you required. So 30 mm above HP is the distance. We need to draw that one with the 1:3 arrowhead, and we need to simply draw this 100 mm and name it 100 mm dimension it is, and its name is A dash and B dash, and we need to project just below that this red color line. How we are going to do? With the help of 2H pencil, I need to draw two perpendiculars. One is in this direction and another one is in this direction, and we need to darken its top view also in this way, and its name is small a and small b. This is the required solution of problem number B. Now problem number C. Line is same 100 mm long and it is parallel to HP and VP both. Line is lying in the VP. Sorry, line is lying in the HP, but 30 mm in front of VP this time. The opposite problem which we have discussed in the previous slide, this problem is just opposite to that one. Line is lying on the HP and in the HP are the same thing. So capital AB is the required line, or you can say given line, which is 30 mm in front of VP, right? And when I am observing from infinite distance from here, my front view is projected on the intersection of HP and VP. This thing, A dash and B dash, which is red in color, is the our front view, and when I am observing this line from the top, this line is projected on the HP itself because line is lying on the HP, it cannot go anywhere else. So small ab is the denotation for its top view. So how we are going to draw the final projection, or you can say final solution? This one is the XY reference line, and first of all I need to draw my top view first, because true length is visible in the top view and also in the front view, but we are going to start with our top view first. So 30 mm below, because after rotating HP 90-degree clockwise, this 30 mm distance is going to downward in below the XY. So this is my required projection of top view, and its name is small AB, right? And the front view is projected just above it. This is the front view projected. Its name is A dash and B dash, and small AB are the top view denotation. So we need to keep the small AB and A dash B dash dark, and also XY as dark, and this dimension line with the help of H pencil, and blue color again is denoting my projection lines, right? So second problem says a line PQ is there which is 80 mm long, and we need to draw its projection for following condition. One by one condition is changing. So in first condition, PQ is vertical. See, PQ is vertical and also perpendicular to HP, but also parallel to VP. So this capital PQ, this is which is black in color, is the given line which is having how much length? 80 mm length. But two more other things are given in the problem. Capital P, or because line has two ends na, Q and P. P end is closer to and 15 mm above HP. See, this small P end is 15 mm above HP, and it is also nearer to HP na, because Q is the farthest end from the HP, and also this small P end is 25 mm in front of VP. So when I am observing from here, from HP side, from front view in finite distance, front view is projected on the VP, which is shown as red in color. So small q dash is the front view denotation for end Q, and small p dash is the denotation for our end P. So this p dash q dash is having the same length as the length of line is there, 80 mm. Okay, and this 15 mm distance which is above HP, when I am observing this line from the top, see, when I am observing from the top, only a dot is visible. This black color dot is denoting my line, because in the top view only a dot is visible. Initially we can see Q, and later on we can see P also. So how we are going to draw its projection? So initially we need to draw a reference line XY in this way, and 15 mm above HP distance initially I need to take, because I need to draw the front view first. So 15 mm above the HP, or you can say above the reference line XY, I need to draw an 80 mm line. Okay, and the lower one end is known as my P dash, and the topmost end is our Q dash, and length of this line is 80 mm, right? And just below this line, but this 25 mm is projected right over here on the HP, and after rotating HP 90-degree clockwise, this line is going to drawn below the XY line in this way. There is a dot, and this dot is lying 25 mm below the XY line, right? And its name is small q comma p. You can also write q and within bracket p. Both are the correct method. And we need to join p dash to qp with the help of 2h pencil, with the help of light pencil. And later on we need to the dimensioning of this thing also, which is 25 mm, right? And this is the final solution of this time. Now 2B part is there, line is having same length 80 mm long, and we need to draw its projection in the given condition. So PQ is this time perpendicular to VP and 30 mm above HP. See, this QP is the given line which is parallel to my HP and perpendicular to VP. You can clearly see that this black color line is perpendicular to VP and parallel to HP. But again he is mentioning another data which is saying that Q is closer to, Q end is closer to and 25 mm in front of VP. See, this Q end is closer to VP. How much? 25 mm in front of VP, but it is closer to VP, and P is the farthest end, or you can say having more distance as compared to Q. And simultaneously my line is 30 mm above HP. It is parallel to HP, but it is 30 mm above HP. When I am observing from the front, I will see P first and later on Q. Only a dot is visible, and I will project it on the VP, and P dash, and within bracket I can write Q dash. Similarly, when I am observing this line from the top, small q and small p, which is red in color, is the required top view. So how I am going to draw this final projection? Because small qp is the top view and it is the true length of line or actual length of line. Length of line is not changing in the top view, but in front view it is only a dot. So we will start with top view first. You can draw front view also, but how we are going to draw this? Initially we need to draw a reference line xy in this way. And how this dot we need to draw first. So this dot is how much? 30 mm. 30 mm above the xy line, and I need to name it p dash and q dash, because initially I will see p and later on q will be visible, but it is behind the p. So p dash and q dash are denotation for that. So this is the 30 mm above xy line. Now this 25 mm distance plus 80 mm distance of line, both are projected below that dot, or you can say below this reference line xy, because we are rotating HP 90-degree clockwise, right? So we need to move 25 mm downward to the xy, and later on we need to draw a line 80 mm long, and its name is Q and P, which is the top view denotation. Now I need to join Q with P dash Q dash, because we need to keep as a light line, because this is nothing but a space in this way. So this is the required projection of this problem, right? Hope you are getting it. Now the problem number 3. A line MN is there. See, a line capital MN is there and having length 90 mm long, and we need to draw its projection in the given condition. What is the given condition? MN is in the, or you can say is on HP. MN is on HP, or you can say in the HP. Both are the same thing. And it is inclined at 45 degree to VP. Now the line is not parallel to HP and VP. Now line is inclined to VP, but the point M is touching the VP at the same time. See, this is my capital MN line, and it is making an angle of 45 degree with this VP, and from the top view we can easily see the angle, because in front view we cannot see this angle. From the top we can see this angle at 45 degree. And this line, capital MN line, black in color, is the given line having length how much? 90 mm. So when I see this line from the top, small m dash, and here we need to write, sorry, small m and small n is the top view. In the top view the length is same, 90 mm. So this is the true length of line, this is the actual length of line, and true length of line is the very important thing which we are going to study in the projection of line inclined to both the planes. And also in the front view, capital N and n dash are on the same line and projected on the intersection of HP and VP. So this red color is denoting that my 90 mm line is getting short, because when I'm observing at an infinite distance my front view, my line is getting short, and in the top view line is having actual length, line is not getting short. So this is the true length. And what I am going to say, listen it very carefully, the view in which my length is not going to change and my true length is visible, I am going to start my solution with the help of that view. In this problem, my true length is visible in top view, so we are going to start our solution with the top view first. Later on we can draw front view, because we don't know the distance of front view in the initial state. So how we are going to draw this solution? Initially, same step, we need to draw reference line xy, and on this line somewhere at any point we need to mark small m first. Why? Because we are going to draw our top view and on that point we need to draw 45-degree angle. And what should be the length of this line? 90 mm line, and this line is at how much angle? 45 degree, right? Small mn is the 90 mm length and angle is 45 degree, but in downward condition, right? So front top view is being drawn, and how much it is length? Its length is 90 mm, and we need to do dimensioning in this manner. Draw an extension line with the help of 2H pencil, and with the help of H pencil we need to draw 1:3 arrowhead, and between the line, or you can say in this position or above the line, we need to write the 90 mm dimension, right? And now we need to draw its front view. I need to project from here in this way, and the intersection is on the xy line, and this point is known as n dash, and this point is the same. M and M dash are lying on the same point. So I need to keep dark M dash and N dash also, because this is my front view and this is my top view. I need to keep dark only front view and top view in the final projection in this way. So this is the required solution, and we don't have any need to tell how much the length of m dash and n dash is there, because examiner is not asking. Examiner is saying that only we need to draw its projection. He is not asking the length. If he is asking length, then you can measure it easily from the scale with the help of scale. So now the problem is very good. A line capital MN is 90 mm long again, and we need to draw its projection. What the condition is saying, that capital MN is inclined at 30 degree to HP and simultaneously parallel to VP. Then only and only condition is this one, that black color is denoting my line which is making an angle of 30 degree. This one is the angle the line is making 30 degree with HP, and the line is parallel to VP. So line is having 30 mm distance in front of VP. So this distance is in front of VP distance, which is the same for point N and M, because line is parallel to VP, right? So for point N and for point M of the line, or you can say an infinite number of points between the line, between point M and N, all are 30 mm in front of VP and M. We are talking about and M is 30 mm, and N is also 30 mm in front of VP, na? Because line is parallel to VP. Now capital M and is also 20 mm above HP. So this is the above HP distance. When I am observing from infinite distance, because this is my HP and VP and both are perpendicular to each other, so I am observing from infinite distance. My line is projected in red color, and M dash and N dash, which is having small denotation, small m dash and small n dash, is the front view denotation. And you can clearly see length of line is not getting changed. Line is having same length 90 mm, and here also 90 mm. And when I am observing this line from the top, line is projected on the HP, and green color is denoting that much length. You can clearly see that small mn, which is green in color, is getting short as respect to 90 mm, and red color is the having same length. So in the front view, see, my line is inclined to HP at some angle, and it is observed as true length in the front view. So we are going to start with front view first. If the line is inclined to VP, then the true length is visible in its top view. So we need to start with top view in that case. But in that case, how we are going to draw the projection? Initially draw a reference line XY having desired length, which are you taking to go, sorry, which you are going to draw, and we need to take initially 20 mm above HP, because we are going to start with front view first, right? So I need to mark a point M where I am going to draw this 30 degree angle, and how much is the above HP distance, which is 20 mm, and below XY there are another point which is known as small m. So this is my 20 mm above HP distance, and this 30 mm. See, this 30 mm distance is projected right here, and after rotating HP 90 degree clockwise, it comes in downward direction. But we are going to start with front view first, right? So how we are going to do that? I need to draw an horizontal line here, and I need to draw 30 degree angle at point number M dash. With the help of protractor, we can easily draw 30 degree line here, and how much length? 90 mm length, because line of line is not getting changed in this condition. So I need to draw how much angle? 30 degree, and let the line go in this direction, but up to how much length? 90 mm length. This length is 90 mm, and the name of this line is M dash and N dash. And how much is the required length? 90 mm, which is given in the problem. So M dash, N dash, N dash is the required front view, or you can say projected front view. Just below that, my top view is being projected. So I need to draw a perpendicular in the downward direction in this way. And again, I need to draw an horizontal line from here, which is parallel to XY in this way. So this intersection point is going to give us point number N in this way. And we don't have any need to do dimensioning for here, because examiner is not asking to you. In some problems, he will give you top view and he will ask you the true length of line, right? So this is the required solution, right? But in upcoming problem, a line MN is 90 mm long, and we need to draw its projection, and in this case capital MN is parallel to HP. You can clearly see line is parallel to HP, but 25 mm above it, but the line is making an angle of 60 degree to VP. Line is making an angle to the VP, but line is parallel to HP. So line is parallel to one plane but inclined to another plane. This line is parallel to HP, but it is inclined to VP at an angle of 60 degree. So in this way, this black color is denoting my given line, capital MN, and this line you can clearly see 25 mm above HP and 15 mm. This my end M is there because N end is the farthest end. I am talking about only end M. M end is 15 mm in front of VP, but 25 mm above HP. Actually, complete line is 25 mm above HP, but the examiner is asking or providing the data in terms of end M for above HP distance, right? And for in front of VP distance, only end M is 15 mm in front of VP, but N end is but at a different distance. So this angle is 60-degree angle. So we can clearly see that in the top view condition, my line is having true length. So this green color is having same length, 90 mm. Length of line is not getting changed. So small mn is the required, or you can say projected top view. So when I am observing this line from the front, you can clearly see my end M is projected right here, and its name is M dash. But for n and n, my n end is projected here. So you can clearly see this red line, or you can say front view M dash n dash is having smaller length as compared to 90 mm, which is the given length of line. So length of line is getting short in front view, and it is having true length in the top view. And again I am going to repeat the view in which the true length of line is visible, we are going to start our solution with that view. So how we are going to draw that solution? We need to draw XY line first, and we need to take 15 mm below distance, and we need to mark my small m and M dash, because M dash is 25 mm above HP, and M is, or you can say top view of capital M is projected just below the XY. So this is 15 mm below, and this is 25 mm above. So we need to do the dimensioning in this manner, and I need to draw an horizontal line here. Okay, and I need to draw 60-degree angle, but in downward direction. And how much should be the length of this line? How much should be the length of this line? Because true length of line is visible in its top view, so this length of line should be how much? 90 mm. And we need to do the dimensioning in this way. So this is my top view, which is known as small mn. Okay, and later on we can do the dimensioning in this way. Draw some extension line, and draw two extension line, and we need to draw dimension line, or either between the dimension line or above the dimension line. We can do the dimensioning. How much? 90 mm. Now I need to draw my front view, because we don't know the length. See, this point is known as my M dash. This point is known as M dash, and I need to find N dash. So I need to draw a perpendicular from in upward direction in this way. In this way I need to draw perpendicular, but how much distance? Up to desired length. We can take up to here also, but later on I need to draw a parallel line to XY, and the intersection point will give us N dash in this way. So this intersection will give us N dash. So this end is M dash, and this end is our N dash, and we need to keep dark only top view and front, right? And these blue color lines which I have marked here, we need to draw with the help of 2H pencil or 3H pencil, whichever you want to draw. So fourth problem is saying that a 100 mm long line is there. A 100 mm long line is there, but line AB is parallel to HP and 40 mm above it. One end of the line is 25 mm in front of VP, and simultaneously line is 40 mm above the HP. See, now the examiner is not giving the angle to us. Examiner is saying that end A is 25 mm in front of VP, and end B is 50 mm in front of VP. So it is understood that if the two ends of line are having different distance from the respective plane, or you can say VP, then the line is inclined, because end A is 25 mm in front of VP, but the end B is double of the 25, you can say 50 mm in front of VP. So it is understood that line is inclined to VP, but line is 40 mm above HP, so it means line is parallel to HP, right? So as we have studied in previous case, its top view will give you the true length, which is named as small AB, or top view of the length of line. But for front view, this is our A dash and projected just behind the A, but for end B, my B dash is projected here, and red color is clearly showing that my line is getting short in length. So again, true length of line is visible in its top view, So we are going to start with top view first, but we don't know the angle, but we can draw this thing because we know the position of end small a and small b. So how we are going to draw this line? Initially we need to draw a reference line xy in this way, and I need to mark my point small a first, and I need to draw a parallel line. I need to draw a parallel line. On this parallel line my end a is going to lie, and I need to draw another line which is also parallel to xy line for end b. We need to mark the locus of end b also and for end a also, and end a is going to lie on this line, and on this line my end small b is going to lie. And how much is the distance? This distance is 25 mm, and this distance is how much? 50 mm. So on these two particular lines my top view is going to lie. So initially I need to mark my point here, and this end is my small a. So I am going to open my compass of how much length? 100 mm length, and I need to put my compass needle over point a, and we need to draw an arc on this locus of end b in this way. So from a to this arc, how much is the distance? True length of line, or you can say 100 mm, and this point is known as my end b, and I need to join a with b. This is the top view, or you can say true length of line. So we need to write 100 mm here. So now I need to draw my front view also. So how we are going to draw? We need to draw two perpendiculars, one from here and one from here. Okay, in this way. This perpendicular, but this distance is how much? This distance is 40 mm. Okay, and why I need to draw perpendicular from here also? But how much distance? 40 mm distance. So this distance we need to take how much? 40 mm, because line is having 40 mm above HP distance, na? So this end is known as A dash and this end is known as B dash. So I need to join it first, and later on we can name it also. So this end is A dash and this end is B dash. So now I can easily measure this angle also. I can easily measure this angle also, how much the angle phi value is there. So this angle phi we can easily measure with the help of protractor, and you need to calculate it, and in the comment section you can write the phi value which I can match with my final solution. So this homework I am giving to you. So problem number 5. Problem number 5 is saying that line RS is there. Line RS is there, but how much? 90 mm long length is there. It is parallel to VP and inclined to HP, but the R end is lying on the HP. The problem is very simple, but the line is, the angle value is not given here, and examiner is saying that and R is 25 mm in front of VP, and we need to find theta when if S is 15 mm above HP. See, this end value from HP to and S value is given to us, total length of line is given to us. We need to find theta, and R and S are having same distance from the VP, because line is parallel to VP but inclined to HP at some angle. I need to find my angle value, and I also need to draw the projection of line also. So how I am going to approach this problem? In the front view, the complete length of line is visible, and R is lying on the HP. So the front view is projected on the intersection of HP and VP, and we need to name as R dash. And also the front view is projected just behind the S, and small s dash is here. So this red color line is having same length. How much? 90 mm, because RS is 90 mm. So true length is visible in its front view, and we can clearly see from the top that just below the S, here my small s is going to lie, and here my small r is going to lie. I forgot to write here. So I can clearly see that my true length is visible in its front view. So I am going to start with front view first. So how we are going to draw this problem? Initially we need to draw in reference line xy, and I know the S distance. I know that my end S is 15 mm above HP. So I need to take 15 mm distance initially, but from the XY reference line, because I am going to start with front view first, right? So this end is how much? What name? S dash. So I need to put the compass needle on S dash, and I can clearly see that true length is visible in its front view. So and R dash is lying on the intersection of HP and VP, na? So XY is denoting that intersection. So I need to put the compass needle on S dash and open the compass. How much length? 90 mm length, because true length is visible, and I need to draw an arc in this way, and this length is how much? 90 mm. and this point is r dash, and I need to join r dash with s dash, and this dimension is how much? 90 mm. So this one is my required front view. Now I can easily measure the angle also, but I need to keep this thing as a dark, but this thing is 25 mm in front of VP, because top view is 25 mm in front of VP, right? So I need to draw perpendicular in this direction, and I need to draw this two perpendiculars I need to draw. I'm again going to show you what we need to do. We need to draw two perpendiculars, one in this direction, but how much distance? 25 mm, because after rotating HP to 90-degree clockwise, this distance is going to downward 25 mm below the XY line, right? So this dimension is 25 mm. Again, I need to draw a perpendicular from this point also. Okay, so in this way, so this end is my small r and this end is my small s. I need to join them, and later on we can do the naming also. This end is small r and this end is small s, and now we can easily measure this angle, because examiner is asking the theta value. Examiner is asking what is the value of theta which the line is making with the HP. So after measuring this angle, this thing I have measured for you, this theta value comes out to be 33.74. When you will draw on your drawing sheet, you can match your solution also with my solution. If it is having a different value, see, two decimal points, 2-3 values can change. It may be 34 degree, it may be 33 degree or 32 degree. But if this value is getting changing much more than that, for example, your value is coming 38 degree or 28 degree, then now, the problem number 6 is saying the front view of line CD appears parallel to XY. So the front view is parallel to my XY line. So we get the first data, front view length C dash D dash. This red line we already know, 65 mm. And also C is 40 mm above HP. Actually complete length of line is 40 mm above HP, but the examiner is saying that length of line is point C is 40 mm above HP, and C is 30 mm in front of VP also, and we need to find the length of line, or you can say true length of line we need to find when it is inclined at 30 degree to VP. So in this case we can clearly see capital CD is inclined at 30 degree to VP, and C end is 30 mm in front of VP and 40 mm above HP, right? But front view length we know, we don't know the true length of line. So in the top view the true length is visible. The green line is the top view of this line, small cd, and small c dash d dash is given to us. Only in this problem we are going to start with front view first. So how we are going to approach this problem? XY is the given line, and examiner is saying that line front view is length of, sorry, the front view of the line is parallel to XY. So I need to draw a parallel line, but above HP distance is also given. So 40 mm above I need to draw a parallel line, but how much length? 65 mm, right? So this is the dimensioning of this line. So this is the required front view, or you can say given data is C dash D dash. This much is given to us in the problem. So now I need to approach for the true length. So I need to project two lines in this way. So 30 mm below XY I need to move, because this 30 mm distance is projected just below the reference line XY after rotating HP 90 degree clockwise. So here it is. So now what we need to do? We need to draw an angle at point C. This point is C point, and at point C I need to draw 30 degree angle but in downward direction. As you can clearly see, small c, which is the top view of the line, is lying just below the c dash. Similarly, the small d is lying just below the d dash. So I need to draw an angle 30 degree in downward direction in this way. Okay, so this length is how much? We don't know this much length. How we are going to calculate it? I need to draw a perpendicular from this in this downward direction, and the intersection point will give my point number small d, because small d is lying just below the d dash, right? In this way. So this intersection is my small d, right? So how much is this much length? We can clearly measure now. And again I am leaving to you that we need to measure the true length and write in the comment section how much the value is coming, right? So this one is the another problem. CD is 120 mm long, but it is parallel to VP, and its top view is measuring 100 mm. See, line is having 120 mm length, but in the top view is looking like 100 mm its length. So length of line is getting short in its top view. So only and only case is possible when the line is inclined to HP. We don't know how much the angle value is because examiner is asking show me the true inclination or what the true length of line is making with my HP. So this length of line is 120 mm and in the top view it is looking like 100 mm and C is 15 mm above HP and 25 mm in front of VP. So in front view true inclination or true length of line is projected on my front view or on VP, and in top view my length of line is projected on the HP. So how I'm going to start with this solution? I need to draw a reference line XY first and I need to mark 2 points. One is C dash and another one is small c. One is 15 mm above HP and another one is 25 mm in front of VP. So this case is it is. So again I need to draw a parallel line because I know the top view length. Okay, I know the top view length of line is looking like 100 mm. So I need to draw a parallel line to XY and how much length? 100 mm. So this length is 100 mm and the denotation for this end and this end are small c and small d. So top view has been drawn. Okay, now I am coming to the front view. I know that my length of line is how much? 120 mm in its front view. So I need to draw a perpendicular in upward direction. Okay, so I need to draw a perpendicular in upward direction. This end is C dash, so I need to draw a perpendicular in upward direction. But how much length? We don't know initially. So how we are going to find end D dash? On the C dash, I need to put a compass because my length of line is 120 mm and its true length is visible in its front view. So I need to put compass needle on C dash and I need to mark an arc on this line in this way. And this intersection point is joined with this C dash. Okay, and 120 mm is the radius of this C dash to D dash, and this intersection is giving the point. So I need to join C dash with D dash in this way. So we need to keep dark C dash D dash and small CD. Later on we can draw a parallel line in this way and we can easily measure this angle now because examiner is asking true inclination, right? So this theta value comes out to be 30 degree. When you draw this particular problem, you can match your solution with my given uh, problem. So this was it from my side. So in upcoming videos, we are going to cover the advanced level problems of projection of lines, in which we will cover the line inclined to both the plane faces. So thank you very much for watching this video. If you like it, do share and subscribe. Thank you very much.